Hello and welcome to another video. In this video, we're going to be working on lexicographical numbers. And this one, you're given an integer n, you want to return all the numbers in the range 1 to n sorted in lexicographical order. And you must write an algorithm that returns in O of n time and uses O of 1 extra space. So hopefully from the last billion dailies, you know what lexicographical means now. But basically it means it's like alphabetical order. So if you turn this into a string, it'll be alphabetical. So like 1 comes before 10, 10 comes before 100, 100 comes before 11, and so on. So yeah. So in this first one, it's 1, 10, and all of these. In the second one, it's 1 and 2. So let's just kind of show what lexicographical order looks like. Like, let's say we have numbers 1 through maybe 25 or something. So what it would look like is like the top level would just be empty, but then you can either have a 1 or a 2. And from a 1 or a 2, so we can actually make this easier. So here, imagine this 1 goes to any one of these 10 through 19, and this 2 goes through any one of these. So basically, you're just saying take this number, multiply by 10, and add any one of these. So this is like the transition states. And we can even say we can have like a bigger range instead of this. We can add a 3 as well, but you kind of get the point. So let's say for a 3, this like maybe we can go to from 1 to 35, let's say. So essentially it'll be something like this. So our range is 1 through 35. So how do we want to build these numbers? Well, we obviously want to start with 1, but then what do we want to do next? Like what's the best operation? So the best operation is to just multiply by 10. So for example, if your number was 1 to a million, the first couple numbers would be like 1, 10, 100, 1,000, and so on. Because adding 1 is worse, right? Like turning this is worse. And adding a 1 here is worse than adding a 0. Like if you had to add something, the best thing you can add is just a 0. So this is the best you can do, is multiply by 10. But what if we can't multiply by 10? What's the next best thing? So like let's say we're at like 30. Like we can't multiply by 10. So what should go after 30? So after 30 should be 31. So the next best thing is add 1. But we can't always add 1 because that's not always going to be the best thing. So imagine an example of like our number is like 10, like let's say we have some bigger numbers and our number is 109. Like we got to 109. So we went from like 1 to 10 to 100 and then like 101 and so on. And then we get to 109. So we can keep adding 1, but then we'll get 110. But 110 is actually just worse than 11. So here we have a restriction where we can add 1 unless that number is mod 9 equals 0, because basically that will change another digit. So we can add 1, we can like modify the last digit, but we can't modify anything before that. So how do we handle that? So here we really want to go back to like the previous state. So imagine our numbers here. Let's go through this example. So we'd have like 1, then 10, then 11, 12, 13, 14, 15, 16, 17, 18. So in this case, it actually doesn't matter. But like if this was a bigger tree, it would matter. Like if this was 100, it would matter because you'd want to go back to 10. But how do you go back? So essentially what you want to do is like you're at this, imagine this is a tree. So here's like level 1, level 2. So you want to go back to the previous level, not all the way to the beginning. You want to go back to the previous level. So previous level and to next number in that level. So how do we do that? Well, whatever number we're at, we can divide by 10. So if we're at 19, we can divide by 10. We go back here, and then we can just add 1 to go to the next one. And if somehow we can't add 1 because like we're at the end of the level, like let's say we're over here, and let's say there are some more levels up here. If we can't, then we'll divide again until we can. So essentially you can think about it like we have this big tree. We're at some level. Let's say we're over here. What we want to do is we want to go up a level and then across. And the way to go up a level and across, because that's going to give you like the next, like if you think about it, if these are all in order, right? If this is like 0, well, I guess these wouldn't be in order. It would be more like, yeah, if this was 0, 1, 2, 3, 4, 5, 6, 7, and then it would be like, yeah, actually this picture wouldn't really work like that, thinking about it, because really what would happen is this level would be, it would be more like this. Like, let's say this also goes to here. Then it would make sense, right? So if we did have something else here, then this would be like 8. And then this can go to another number, and that would make sense, right? So essentially, like, you know, if this was like, this is 10, this is like, or whatever, this is like 100, this is 110, 120, 130, and so on. So that's the idea. We want to go up a level and then across. But sometimes we can't go across because there's like nothing there. So if we can't go across, then we'll just go up another level, and we'll just keep going up another level and so on. So that's basically what we need to do. So here, so to go back, we need to divide until we can go right. And how do we know we can go right? Well, that's if we can add 1 and not have this mod 9 thing. So in this example, we'd have 19, we would divide by 10, we would get 2, or 1, and then we would add 1 and get 2. So here, this would be 2. And then we do the same thing. We'd keep adding 1, or multiply by 10 is best, so 21, 22, 23, 24, 25. And you can run this through like big edge cases. I just don't want to show that here because it's going to be like a billion numbers. But then you can see why it makes sense. Like here you could have, or actually no, you couldn't, right? So here from 19, you couldn't add 1 and go to 20. So it does actually show it. Like 19 plus 1 would be 20, but we actually want to go back to 2. So even something as small as this shows it. And same thing here. If we had 1, we'd go to 30, but 3 is better. So we would divide by 10 and then go to the right. So 3, 30, 31, 32, 33, 34, 35. And then we can just have a check that says like, while our result isn't long enough, let's just keep adding stuff. Okay, so that's what we're going to do. I would say actually like backtracking with a DFS is easier, where you just plop on numbers in the range of 1 to 10 to yours and make this tree. And I would argue that that's actually O of 1 space, because the maximum depth, like if n is like a million or something, is like 6. So it's still basically O of 1 space. So I would argue that's also like O of 1 time, or O of n time O of 1 space. And it's a little bit easier to see. This one with like the stack type thing and the going back and forth is a little bit trickier. But it never hurts to learn both. So okay, so what we're gonna have is we're gonna have this list integer result. And then what we're going to do is we're going to add 1 to it, because that's like our first number. And then we can just say like while result size is less than n. So the number we're using is based off of just the last number in our result, right? Like whatever number is in the result, we're going to try to multiply by 10. If we can't do that, we'll try to add 1. If we can't do that, we'll go back. So int cur equals get last. We can do. So we get our number, and if cur times 10 is less than or equal to n, then we'll just do that. And continue. And otherwise, we're just going to have a while loop that will drop this number until we can add 1 to it. So while cur plus 1 is either greater than n, or cur mod 9 equals 0, or cur mod 10 equals 9, either one. So this can't end with a 9, basically. So while this is the case, we're going to divide it by 10. And then we should have a valid number, so now we'll just go result add cur plus 1. And at the end, we just return result. So let's give that a try. Okay. Okay, there we go. So this is O of n, where n is like the n in there and space. So we're just using a while loop. It's iterative now, and we're basically moving our number back and forth. So yeah. Like I said, I think DFS is going to be easier to code. So if this is like an interview setting, I'd probably just code DFS because it's a little bit more confusing. And yeah, DFS is pretty easy. You would just have your number, like whatever. You can just loop from 1 to 10, or not from 1 to 10, from 1 to 9. And then for all those numbers, just keep adding anything from 0 to 9 until you're out of bounds. And then, yeah, basically like that. So you do have to do it in the right order still, because you're like, you still want to multiply first and things. But yeah, I think DFS is a little bit simpler. But in either case, this is a solution this way. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you next one. Thanks for watching.